Okay, I want you to imagine something. Imagine a world where every single secret you have, every dollar in your bank account, really every piece of digital security that we've ever built could just vanish in an instant. Now, this isn't some sci-fi movie plot. This is a future we are actively racing towards right now.
I mean, really think about that for a second. The entire foundation of our modern world, your banking, your passwords, even national security, it's all built on a very specific kind of digital lock. And right now, someone is building the universal key. And they're building it with a new kind of machine, one that doesn't play by our rules at all. It's a machine that taps into the bizarre, almost magical laws of quantum physics to do what we once thought was, well, impossible. So what we're really talking about here is a fundamental threat to the digital age itself, a coming collapse. And it's not being caused by some virus or a clever hacker, but by a completely revolutionary leap in how we compute.
Okay, so what is this machine? The one that could bring our entire digital world to its knees? Well, to really get the threat, you first have to understand the weapon.
All right, so every computer you've ever touched, your phone, your laptop, it works with bits. They're like tiny little light switches, either on or off, a 1 or a 0. Super simple. But a quantum computer, that uses something totally different, called a qubit. And you should think of a qubit less like a switch and more like a spinning coin. While it's flipping in the air, it's not heads or tails, it's kind of both at the same time.
That spinning coin state, that's a real thing. It's called superposition. And this one idea, this one property, completely shatters the limits of normal computers. A machine that can explore both on and off at the same time, well, that means it can process an absolutely insane number of possibilities all at once.
And if you think that's weird, it gets stranger. Qubits can become entangled. This is where it gets really mind-bending. It means two qubits can get linked together in this deep, kind of spooky way. If you look at one, you instantly know the state of the other one, even if it's literally on the other side of the galaxy. And this crazy interconnectedness, it just massively boosts the machine's power. So here's the bottom line. Imagine you're trying to break a lock. A normal computer, it has to try every single key one by one by one. It could take forever. A quantum computer, because of superposition, can basically try millions of keys all at the exact same time. The problem isn't just solved faster, it's like it's being solved in a completely different reality.
Right. And that incredible reality-bending power, it has a very, very dark side. Because that ability to check millions of keys at once, it's pointed like a weapon, directly at the heart of our entire digital security system, encryption. Every single day, your online life is protected by these digital shields. You might not know their names, but things like RSA and ECC encryption, they are the absolute bedrock of everything. Secure messaging, online banking, you name it, they are the locks on literally every digital door you use. And here's why they work. Their strength comes from one simple fact. They're based on math problems that are so ridiculously hard that even the biggest supercomputers on Earth would take, like, billions of years to solve them. Let that sink in. Our entire global security system rests on one single assumption, that these problems are basically impossible to solve. Well, that assumption is about to be completely shattered. See, back in 1994, a mathematician named Peter Shor came up with the perfect weapon for the attack. It's an algorithm that can solve those impossible problems with, frankly, terrifying ease, if you have a powerful enough quantum computer to run it on. Shor's algorithm, that is the master key. And the moment a machine exists that can run that algorithm, the consequences are, well, they're immediate. And they're catastrophic. All the digital locks just break. Bank accounts can be emptied, your private messages can be read by anyone, military comms get intercepted, government secrets are exposed, and the entire world of cryptocurrency could just crumble to dust overnight.
There's actually a name for this moment. Experts call it Q-Day. It's the hypothetical day when our digital shields become completely useless. It's pretty much doomsday for data security as we know it.
And listen, this isn't some far-off, theoretical problem for our grandkids. Right now, today, there is a silent arms race going on. The world's biggest companies, the most powerful nations on Earth, they are all in a flat-out sprint to build the very machine that will bring about Q-Day. You've got tech giants like Google and IBM making just unbelievable progress. You have governments, especially the US and China, pouring billions of dollars into their national labs. I mean, think about this. Back in 2019, Google actually claimed quantum supremacy when its machine solved a problem in just minutes that would take the world's best supercomputer literally thousands of years. So yeah, this race is very, very real. But here's the wild paradox in all of this. The very same machine that could completely destroy our digital world, it could also be the key to building a much, much better physical one. It could lead us to a future with just unbelievable promise.
Okay, let's talk about medicine. Quantum computers are absolute masters at simulating reality. They could model molecules with perfect accuracy. This means we could design life-saving drugs, personalized medicines not in decades but in minutes. Or what about the biggest challenges we face as a species? Imagine simulating the exact reactions needed to create revolutionary new kinds of batteries for clean energy. Or building climate models so insanely accurate that we could finally get ahead of global warming. And of course, this power would just supercharge everything else. It would accelerate AI development beyond what we can imagine. It would let us run financial market simulations that are so complex, we might even be able to prevent economic crashes before they even start.
But with all of that incredible promise comes the shadow. For every cure it could create, there's a code it can break. And this brings us to the other race, the second and arguably more urgent race, the race to defend ourselves against the very machines we're so desperate to build.
Now, the world's top cryptographers, they aren't just sitting around waiting for the worst to happen. They are working frantically on a new kind of shield. It's called post-quantum cryptography. Basically, these are brand new encryption methods built on different kinds of math problems, ones that we think will be hard for both normal and quantum computers to solve. The goal? Upgrade the entire planet's security before Q-Day gets here. But that leads to one final, really chilling thought. The bad guys? They know Q-Day is coming too. And experts are pretty sure they're using a strategy called harvest now, decrypt later. What does that mean? It means they are stealing huge amounts of encrypted data right now. Government secrets, your private data, everything. And they're just storing it, patiently waiting for the day they finally get their hands on that quantum key to unlock it all. So you see, the quantum era isn't coming. It's being built right now in labs all over the world. These machines, they're going to completely redefine what's possible, for good and for bad. They won't just change our world, they're going to force us to rebuild our entire digital foundation from the ground up. And the only real question left is, when they finally get here, will we be ready?